Word problems can be tricky because sometimes it feels like there's a lot of information, but if you kind of just go through these steps, what you'll find is that they end up being like pretty similar, and you can kind of always follow the same steps. So the first thing you're going to do is you're going to define your variables. That means like, what are the two letters in the problem? And here's the thing, it's always going to be things that either change. Sometimes variables are things that change. Vary means change. Or sometimes it's things that change or are unknown. So you're either trying to find the value of something that you don't know, like how many bikes are in the bike store. Or sometimes you're trying to find, like in this case, for example, we have like a number of games. Well, that number of games can change. If I buy more games, then that number gets bigger, right? So it's either things that change or that are unknown. I would really recommend choosing logical letters. You could just choose X and Y every time, that's totally fine, but it just makes your life a little bit easier to have like B equals big, right? Like it just makes sense when you kind of working on the problem, you won't lose track of it. Okay, then you're gonna write your equations. You're gonna ask yourself, what do you know about the variables and how are they related? You're gonna write two equations that express this relationship. This is the hardest part, and you'll see examples. Then you're gonna ask yourself what the best method is to solve. If they're both in standard form, you're going to use elimination, right? You're just going to stack them on top of each other. Sometimes you'll need to multiply one of the equations. You're going to use elimination. If they're both in slope-intercept form, you'll use substitution, where you say, oh, like if this is equal to y and this is equal to y, then these two things must be equal to each other, right? And sometimes, occasionally, though this is very unusual in word problems, you'll get one standard and one slope-intercept, and you would use substitution for this as well. Once you solve, right? That means you get the value of both variables, right? You need the value of both variables. You'll check your answer. You can either kind of read the original sentence and original equation, or you can plug them back into your original equations, right? You can plug those numbers back in. And then make sure you write your answer in a complete sentence, right? So like if the problem is how many of each type of bike are there, your answer isn't like 4, 5, right? That's a math answer. You have to actually answer the question. All right, here's your first example. There are 26 bikes at a bike store. Some are tricycles and some are regular two-wheel bikes. There are a total of 61 wheels. How many of each type of bike are there? Okay, so the first thing we're going to do is define our variables. Now, our question is very specifically asking us, how much of each type of bike are there? Okay, well, those are our unknown values. We don't know how many tricycles and how many regular two-wheel bikes. So let's do T for tricycles and B for regular bikes. Okay, notice I'm actually writing this. I'm taking a moment to write it because that is just going to make my life so much easier later on. Okay, so I've defined my variables. That's step 1. Now I'm going to write my equations. What do I know about the variables? Okay, I know that there are 26 bikes at the bike store. So the first thing I know is that the number of tricycles plus the number of bikes, there's a total of 26 of them, right? The number of tricycles plus the number of bikes is 26, right? There are 26 total. All right, so that's the first thing I know. Now, the next thing I know is that there's 61 wheels. Okay, so if there's a tricycle, how many wheels does it have? Okay, this has 3 wheels. Look, I'm just going to put like a little, right? That has 3 wheels. And a two-wheel bike has, obviously, 2 wheels. So if I have tricycles, I'm going to take the number of tricycles and multiply the number of tricycles times 3. That's how many tricycle wheels there are. Then I'm going to take the number of bikes and I'm going to multiply the number of bikes times 2. That's the number of bike wheels there are, right? Like let's say there's 10 bikes. That means there's 20 bike wheels. Let's say there's 10 tricycles. That means there's 30 tricycle wheels, right? I'm multiplying because for each tricycle, there's 3 wheels. Now, if I add up the tricycle wheels and the bicycle wheels, there's a total of 61 wheels. Okay, I just did step 2. I wrote the equations. Okay, step 3, choose the best method to solve. I notice these are both in standard form, right? Variable plus variable equals a number, right? This, like, it's a number times a variable plus a number times a variable equals a number. This is standard form, right? So here I'm going to use elimination. So step 3, I've chosen my method, it's elimination. Now I'm going to solve. In this case, I notice like elimination is perfect when I can just like, oh, just add these equations together and one cancels. That's not the case here, but I can set myself up to cancel. So I can either choose the T or the B. Let's say I chose the T. And I said, okay, I'm going to cancel the T's. Well, this is 3T, and I'm thinking to myself, I wish this was negative 3T. So I would take this top equation, and I would multiply the whole thing by negative 3. Or alternatively, I could choose the B and say, oh, this is 2B. I wish this was negative 2B. And then I can multiply the whole top equation by negative 2. I'm going to go ahead and multiply by negative 2. Just, I don't know, I like to choose a smaller number when I can. So I'm going to multiply this. And so this is negative 2 times t, negative 2 times b, that's negative 2b, and negative 2 times 26. Make sure you remember to multiply all the way through and watch your signs. Negative times positive is negative, and 2 times 26 is 52. Okay, then I'm not going to do anything to this equation. I'm just going to copy it underneath. Okay, and now I'm just solving using elimination. So now I'm ready to add these together. Why? Because look, this is going to cancel. Negative 2b plus 2b, that's 0. So now let's do this math now. Negative 2t plus 3t, that's 1t, which is just t. And this is negative 52 plus 61. That's the same as 61 minus 52, which is 9. Okay, so I get t equals 9. So far, I have discovered that there are 9 tricycles. Okay, now I need to find out how many bikes there are. Now, you could plug this 9 back into either equation here or here. For me, I look at this first equation and I realize, oh, the number of tricycles plus the number of bikes equals 26. So I'm just going to keep my life simple here, and I'm going to say, oh, the number of tricycles plus the number of bikes equals 26. And then I'm just figuring out 9 plus what number is 26. And I can do it like this. And I get 17. Okay, now what I'm going to do is now I'm going to check my answer. Okay, so I solved. Now I'm going to check. What am I checking? I'm checking if it fits in the original problem. Let's see. If there's 9 tricycles and they have 3 wheels each, that's 27 wheels. And if there's 17 bikes times 2 wheels each, that's 34 wheels. Okay, those add up to 26, good. And then when I add these up, do I get 61? Oh, I do. Okay, so perfect. So my answer looks good. So now I'm going to write my answer. There are, and what's great about my, look, see how I wrote this here? Okay, I'm saying t equals 9. Oh, that's 9 tricycles. There are 9 tricycles, and B is bikes, 17 bikes. Your turn.